I'm going to start recording. I apologize. I should have been doing this earlier so I could put it up, but okay. Okay, so a couple steps. I know I've been jumping around. I apologize. So in this problem, we condensed these into a single log, and then we analyzed it. We said, oh, if we have one log equaling one log, the log part must not have been important. It must have been only the 12x plus 30 must equal the 150. Okay. And that was the logic. And again, you guys can, I think the answer is 10 or something like that. Okay. Is that okay, everybody? Or do we have other questions or more on this or whatever?
Yeah, the answer is 10.
Yeah. But I'm more concerned at this point, not with the answer, but with the logic behind the problem, setting the problem up, knowing why you're doing a step. Okay. Any other problems on any of the exams? 2, 3.
Real quick, did you get 10 just punching it into the calculator, Mel?
Yeah, well, you said to Mel or me?
Or whoever, because she had it right there.
I mentally took 30 away from both sides and said that's 120.
Oh,
So
okay.
12 goes into 120 10 times. So I just did the arithmetic in my head. But if you downloaded the solutions, they're on the solutions too.
Okay. Oh yeah, I have them right here in my packet. Yeah. So
cool. Yeah, they're all there too. But I just did the mental arithmetic very quickly. That's why I keep making mistakes in class, because I do mental arithmetic and we know there's very few brain cells left. Others?
Can you do from exam 4, 6B?
Find it. Exam 4, 6B. Yes, I can. Okay. The analysis that you had to bring to this problem was what conic was it? So this is exam number 4, 6B. It was x plus 3 quantity squared over 4 plus y minus 2 quantity squared over 49 equals 1. So first off, which conic is this? Of the things we study, which shape is this?
Ellipse.
How do you know it's not a circle?
The numbers in the bottom.
Good. Okay. How do you know it's not a parabola? Ah, I gotcha. Everybody, not just you. If you remember, parabolas only had one variable squared. Y equals x squared. And yeah, I know there's other junk b, bx, and c, and h, and all that crud. But if this was a parabola, or if you had x equals y squared, you know, and again, there could be other garbage here. These were parabolas. This was an up-down parabola, or this was a sideways parabola. So, okay, parabolas only had one variable being squared. Ellipses and circles had both variables being squared, but ellipses had somebody in the bottom. So that's one thing. This is an ellipse. Second thing on this one, what's wrong with the way it's written? It's not a big mistake, and most of you caught it, but what's wrong with the way it's written?
4 and 9 are already squared.
So what do you have to do to them?
Square root them.
Yes. So you have to rewrite it as this over 2 squared plus y minus 2 coni squared over 7 squared equals 1. That's because then our center was negative 3, comma 2. Our x radius was 2 because it was under the x value, and the y radius was 7 because it was under the y. And you could either rewrite the problem, instead of saying 49, you could write it 7 squared, or most of you just kind of did it automatically in your work. You didn't rewrite the problem. All right, but that's the thinking that has to go on. So having done that, excuse me, then negative 3, 2. Here's our center at negative 3, comma 2. The x radius says from the center, you go in the x direction 2. So you come over 2 units this way, 1, 2, or 2 units this way, 1, 2. And those become your x endpoints, or they're technically called vertices. Okay, but you do that. Now, how do you label that? If you come back 2 units, this one was negative 1, comma 2, or this one here was negative 5, comma 2. So I'm doing a lot of mental arithmetic. I'm taking negative 3, minusing 2 to get to negative 5. And I'm taking negative 3, plusing 2 to get to there. Then I take the y value, 7, from here. So if I go up 7, 1, 2, 3, 4, 5, 6, 7, or down 7, 1, 2, 5, 6, 7, wherever. So this point would be negative 3, comma negative 5, because I had 2 down 7. 2 take away 7 is negative 5. This would be negative 3, comma 9 up here. And all that's left for me to do is connect the dots and make a nice pretty ellipse. And that was it. Okay. That was for number 6D. Anything else on, well, anywhere, it doesn't matter. We can jump to anything. Oh, I know what I want to show you guys, because I don't want to do this again to you on the final. Okay. What's the domain of this problem up here? I know I didn't ask it on the test, but I'm asking it here. Okay, what's the domain of this problem?
-5, -1.
Okay. I agree with that, except I had several people do that. And that's wrong. That's wrong. Okay.
It's brackets, huh?
This- Brackets, yes. Okay, because we want to technically this means just the number -5 and just the number 1. If you want to include everything between -5 and 1, you need to write this as bracket -5, -1. Okay, this technically means just the single number -5 and -1. It doesn't mean and all the other stuff in between. So all those little symbols, that's part of you becoming an advanced mathematician, an advanced math student. And that's where you guys are headed. This class is supposed to take you to calculus or be an introduction to stuff. So all these stupid little symbols have meaning. And we got to get them straight sooner rather than later, I would hope. Okay. Other questions anywhere? Exam 2, 3, 4. Do you know how to factor? Do you know how to do substitution? Do you know? I don't know. There's all kinds of crap.
Can we do from exam 2, number, I don't know, 14?
Just making this up. Pick one, anyone. I want 14. Okay. Yeah, we can. All right. Can I erase this work here for the ellipse? Is this okay with everybody? Okay.
Yeah.
So exam 2. Number 14, we have 16 over 5 times the square root of 10. Okay. Well, what's wrong with it? Why do we have to simplify it? That's what the directions say.
You cannot root on the bottom.
Right. Okay. Now, I do need to warn you that in future classes, probably 2 semesters from now, they'll say, yeah, sometimes you can have a radical in the bottom. Okay. But they'll let you know when that rule shows up. But right now, standard algebra says you can't have a radical in the denominator of your final answer. Okay. So the way we did that is we multiplied top and bottom by the square root of 10. Now there's a shortcut that I'm not going to take. Because what happens here is we get 16 radical 10 over 5 radical 10 squared. Okay? Because when you multiply, you go outside, outside, inside, inside. So you get the square root of 10 squared. Well, what happens with the square root of 10 squared? What happens there?
Becomes
Cancel.
5 times 10.
Okay, what cancels? I'm sorry, I think you answered it. The radical and the square power cancel. What are you left with?
5 times 10.
Right, okay, yeah, 2 people and 3 people were talking, so I didn't hear you clearly, my bad. So 16 radical 10 over the original 5 times normal 10. That junk there canceled out. Now at this point, you can reduce or not reduce at your choice. Eventually you have to reduce. So this is 16 radical 10 over 50. But guess what? 16 over 50 just does normal reducing. Okay, 16 over 50 divides by 2, so that's 8 radical 10 over 25. And we would be done.
Okay, thank you.
Yeah, well, that brings up then an interesting problem. Again, I want to riff on that. Riff on it, I'm sorry. What if you had seven over the cube root of 5x squared? How do you get rid of the cube root top and bottom?
Multiply by 3?
No.
No.
Move them out.
Multiply by x.
X is part of the answer.
Would it be
Again.
25x
Bingo. Very good. Why?
in order to make it to 5 to the third power and x to the third power?
Brilliant. That's exactly right. Back over here, okay, a lot of people just go, okay, square root of 10 times square root of 10 is regular 10, and they just blow it off and go, I'm done. But there's a thought process behind all of this. Because this was a square root, you wanted to make everything inside a perfect square. Okay, and then we know that if you have a perfect square inside of a square root, they cancel and life is good. But this is a cube root, so we have to get perfect cubes inside. And so we multiply top and bottom by 5 squared times x. And we kind of pulled that out of thin air. Because we said, okay, to get out of a cube root, I need 3 of something. So I need 3 5s. I have one of them, I need 2 more. Okay, to get out of a cube root, I need 3 x's. I have 2, I need 1 more. So that's the thinking that goes on. You know, where did you magically pull this from? So putting all this junk together, you get 7 times the cube root of 25x, because that's what 5 squared is, over the cube root of 5 cubed x cubed. Because you made them perfect cubes inside of a cube root. Now you can pull everybody out. So this is 7 cube roots of 25x on top over, now that they're cubes inside of a cube root, you can pull the 5 out and you can pull the x out and you're done. This would be the answer to this problem. Okay. We hadn't done those in a while. I think the handout I gave you, yeah, on exam 2, it says chapter 8 intermediate, rationalized radical expressions, that one may include radicals with indices of 2, 3, or 4. So here we're rationalizing a cube root. Okay, still on this. What if I have 7 over 5 plus the square root of 6? Okay. How do I fix that one?
5 minus the square root of 6.
Right, that's called the conjugate. So you're going to multiply by 5 minus the square root of 6 to top and bottom. Okay. Giving us 7, well, okay, I'm going to skip it right now. 35 minus 7 radical 6 over. Now, I saw some people try and use the matrix box and they really blew it. And I don't know what happened, but okay, we set this up as 5 plus radical 6 and 5 minus radical 6. I see my, yeah, okay. So that's what you're multiplying here. 5 times 5 is 25. 5 times negative 6, negative is negative 5 rad 6. Radical 6 times 5 is positive 5 rad 6. And radical 6 is negative radical 36. But that's the same as negative 6. So somehow a few of you really botched multiplying this matrix method. And I know some of you don't use it. Some of you use a method called FOIL. That's fine. Okay. But you got to be able to multiply these together. These are going to become 25 minus 6, which is 19. So your final answer is 35 minus 7 radical 6 over 19. And that would be your final answer. So 3 types of simplifying radicals, a simple square root, cube root, a little bit of thinking that goes in here, and then a binomial where you end up multiplying by the conjugate to top and bottom. Now I'll be quiet and answer more questions. I'd mute you guys all. So you have to unmute yourself. Any
How
questions?
about,
in
how
Go
about
ahead.
4A off of exam 3, I believe. Yeah, exam 3.
4, 3, 3. 2 times square root of -6, that one?
4A?
Oh, 4A, I'm sorry. Yeah, that's the f of g of -3, that one?
Yeah.
Okay. Okay. Exam number 3. Okay, first we were told that f of x is x squared plus 2x, and g of x was 2x minus 1. And they want us to find f of g of -3. Okay. So like in PIMDAS, we start on the inside first. Well, the inside has a -3. But what's it asking me to do? Plug it into the g function. So I go off to my scratch paper and I take the g function and I plug -3 into that. So that's going to be 2 times -3 minus 1, which is -6 minus 1, which is -7. So what I just said is g of -3 is worth -7. That means this problem has become f of -7. So I replace g of -3 with the value -7 because of this work here. Well, what's this asking me to do? It's saying take the -7 and plug it into the f function. Well, f of -7 is -7 quantity squared, notice my use of parentheses, plus 2 times -7. -7 squared is positive 49 plus a -14, that's positive 35. So I've just figured out that f of -7 is worth 35. So that means my final answer here is 35. And that's it, and I'm done. And I fully accept that a lot of this work could have been done in your head, but you had to know the concept. So I'm trying to show you the thinking that goes on to get these. Questions? I agree. I have questions too. Okay, anybody else? Any questions at all on exam 3, exam 4, anything? Exam 2?
Can we do the special triangles?
Sure. Which one? There's 3 or 4 of them, 2 or 3 of them, whatever. Where's my number 4? We can do those. We can also do,
On exam 4, I think it was like the last question with the The last two questions?
Okay, solve the triangle.
Yes.
Okay, all right. Exam number, oops, 4. Problem either 14 or 15A. My numbering was screwed. It said solve the triangle. And solve meant find all the missing sides and angles. So the triangle, the first one, I'll do the second one in a minute. But the first one was here. This is 5, 13, and this is a right angle. So solve in the directions said find all the missing sides and missing angles. Okay, well, the first thing I see that's missing is this side right here. Okay. What can I use to find that side, that X? I got formulas of the yin yang. I got Sohcahtoa. I got 30, 60, 90 triangles. I've got Pythagoras. Which one do I use and why?
Pythagoras, because it's sides.
Pythagoras, because it's the sides. That's a great answer. Pythagoras formula, Pythagorean formula is for the sides and only the sides of a right triangle. So you can say something like, okay, this is x squared plus 5 squared equals 13 squared. X squared plus 25 equals 169. X squared is 144. X is technically, in algebra, we'd say plus or minus 12. Okay, in algebra, we would say plus or minus 12, but because this is a geometry triangle, we say it's only 12, because a triangle can't have a negative side length. So that's the first thing. So suddenly this triangle, okay, turned into 12 and 5 and 13. And I would have used Pythagoras. Is that okay? Going from, here's the original triangle as it was written in your test, and then here's the work to figure out that side was 12. Okay, now I have to find the missing angles. Okay, and this is where Sohcahtoa comes in. Sohcahtoa is a formula that uses angles and sides. Okay, when we wrote a trig expression, some trig like sine, cosine, tangent, okay, it was always trig of an angle, sine of an angle, cosine of an angle, or whatever, equals some side divided by some other side. That was always the formula. So this showed the relationship between the two sides of a triangle are somehow related to the angle. And we always put the angle with the trig thing, sine, cosine, tangent. So what we had to do is decide which angle do I want to find first. Do I want to find this one down here or this one up here? It doesn't matter. Let's find this one down here. Let's just say I want to find that one. Okay. So what sides, I have my angle X. What sides is it related to? What do I want to use?
Cosine.
Okay, so if you say cosine, remember, Sohcahtoa, the cosine is the adjacent
Adjacent or hypotenuse.
over hypotenuse. Now, you could have used sine also, but then that would have involved the 12, but cosine is great. So we write this equation. We say the cosine of angle X is 5/13. The cosine of angle X is 5/13. Now, does that make sense? A few of you are really mixed up on this. One or two of you. Is that okay with everybody? We pick cosine, fine. But we had to know that cosine is related to the adjacent side, adjacent to this angle, divided by the hypotenuse. So that's why we pick 5 and 13. All right. Technically, to get cosine alone, we wrong. To get X alone, we inverse cosine both sides. Just like we ln'd both sides to get rid of the E. Okay. Now I saw some people trying to jump from this picture down to some other equation here, and you can't do that. You confuse yourself. You have to start with this equation. That has to be your starting equation. Then you can begin to use algebra to manipulate it, but you have to have that equation first. So you inverse cosine both sides. The inverse cosine cancels the cosine, you get X equals the inverse cosine of this mess. And that's just on your calculator. Do I have my calculator? I'm in the dark and my calculator is a solar one, so what happened? Yeah. No, let's try my other one. Okay, and if my calculator is screwed up, I get 65.37568. But the test said round to nearest 10th. So this would be X is approximately 65.4 degrees. Okay. So now my picture looks like this. 5, 12, 13, 65.4 degrees. Okay, I'm not quite done, but we're almost. How are you guys doing in terms of following my work and my logic? Yes or no? Are you guys okay with all of this or not?
I mean, this is a personal problem, but my calculator gives me, like, I have two modes, like comp or stat, and comp gives me an error when I do the inverse. And then when I go to stats, it gives me 67.38. So I got that wrong on the test because of my calculator. It's gonna suck.
I'm using mine. Okay.
Anybody else? Anyone else confirm?
Well, wait a minute. I stop being lazy. Mode. You got the Casio, right?
Mm-hmm.
Okay. So let me do 5. Inverse cosine of 5 divided by 12 closed. 65 point. Okay, I get the same answer.
Okay.
So
I'll show you my calculator on Tuesday and maybe
yeah,
we can figure it out.
we'll figure out what's happening because you're going to want to use that in a future class. So
Right.
we'll figure out how to get it right on there.
Okay.
Okay?
Thank you.
Yeah, no problem. Okay, now, question. Remember, we're the lazy mathematicians of the world. I want to find this answer up here because it said find all the missing angles and all the missing sides. How do I find this angle up here?
I said,
Hmm?
Elliot showed me.
Anyone?
180 minus 90 minus 65.4.
Yeah, that's it. Or, you know the three angles, if this is 90, then you also know that the two acute angles, x plus 65.4, has to be the other 90. Because a triangle always adds up to 180. So you got 90 here, and these two also must be 90. So a slightly faster way is to say, okay, these two acute angles have to be 90. So whatever you do. I mean, I don't care how you do it, but that's just should be arithmetic. So if I minus 90,
24.6.
yeah, that's what I get, 24.6. And that's the answer. So on this particular problem, you only had to use the trig stuff once. You use Pythagoras, which we've been using since chapter 2. Go back, check your notes. Okay. And we use the idea that the angles of a triangle add up to 180 to find the other one. So the only thing that was really new was this one step in the middle. Now I'll do the other one in just a second, but I'm going to have to erase this. Okay. So any questions on any of my work, any of the logic? Why did I do a certain step? Any questions there? Okay, then I'll erase and do the other one. Okay, it was number B, letter B, and it was 40, 80, and a right triangle. So we have this picture. Okay, be lazy. We're supposed to find all the missing sides and all the missing angles. Quick, how do you get one almost free point?
The angles, one is it's 50, the missing one.
Yes, real quick, we know that those have to add up to 180, 90, 40, and what, maybe 180, 50. So I should have got you 1 point right there on that one. Okay, so now I want to find one of the sides. Okay, let's just say I want to find this side. I just picked one. Call it X. I want to find it. How do I use the information in the triangle, okay, to get to here? Knowing I have an angle and a hypotenuse. So I have an angle. I can either use the 50 and the side and the hypotenuse, or I can use the 40 and the side and the hypotenuse.
If you use the 40, you'll use sine
Okay.
for
good.
opposite and hypotenuse.
Yes. So if you use the 40, okay, the sine says use the opposite over the hypotenuse. So if you use the 40, you say the sine of 40, that's my trig of an angle, is the opposite side, x over 80. Okay, what if I wanted to what if I wanted to use the 50? what if I wanted to use the 50 and find X? What do I do then?
Cosine.
50 and X, you would use the cosine of 50 equals X over 80. Both of those will give you the same answer. But notice one is a sine equation. So the sine of 40 on your calculator is different than the sine of 50. Okay, well, actually, it's the same as the sine of 50, I should have said. I'm sorry. Okay, but they'll give you the same answer. That's a guarantee. So anyway, then what I did is I cheated a 1, so I cross multiply, and I had 80 times the sine of 40 equals X, and now I'm just doing stuff on my calculator. Okay. 40 sine times 80. I get 51.42. Something, 423.
Correct.
Okay, and it told me round to nearest 10th again, so I'm going to say 51.4 equals X. Okay, so let's look at the picture. What do I have here? I've got 51.4. This is 50. This is 40. I'll get out of the way in a minute. This is 80. Okay. I still need to find this side. Two ways I can do it. What's one way?
Pythagoras.
Pythagoras again. Okay. You could say that X squared plus 51.4 squared equals 80 squared and work that one out. Or you could use Sohcahtoa again to find this X. So we could say something like the cosine of 40 is X over 80. Oops, X over 80. Because the cosine is the adjacent. So if we use the 40, X is adjacent, 80 is the hypotenuse. So the cosine is adjacent over hypotenuse. So you could write that equation. Okay. If you want to use the 50, you can say the cosine of the 50. No, excuse me, not cosine. The sine of the 50 is X over 80. Because from the 50, this is opposite. Sine is opposite over hypotenuse. So you actually had three different ways you could have found this side. You could have used Pythagoras, or you could have used sine or cosine, but you had to use the right angle and all that kind of stuff. Right sine and cosine. And I forget what my answers were for that one. Bonus number, which one was this? Oh, this may be the bonus. Boom, 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 boom. 61.28 is what I got. Round 61.3 rounded to 10th. That okay or not okay? Or other questions, moving on to something else. Yeah, that's the fastest hour and a half I've ever done. Few more questions. Couple more. This should kind of whet your appetite. Study a little bit tomorrow and then bring more classes on Tuesday, more questions on Tuesday. Tuesday is going to be a whole lot the same as this day. Yeah, go ahead.
Exam number 3, number 2B.
Okay, good question. Exam number 3.
Are we gonna be allowed to use our, what is it, 3x4 index cards?
No,
No,
that was only because you had a whole lot to remember on this one test.
okay, so just
And
no,
every-
so.
No. Yeah, well, there may be, but you've had now a chance and, okay, a couple things. First off, each night the test will be very short. This technically, if you want to stay there a long time, most of you should be able to finish the final exam in one night. But I wanted to break it up so that you knew what was on each part. You could focus and study each part and come to class just studying those. Okay, so I feel that in that situation, since it's a short test, technically each night is a short test. And I've told you pretty much what's on it. You should be able to come up with all those formulas, at least memorize them for one night. Remember, you can still use the brain dump. You still have everything in your head, write it on a blank piece of paper when you walk into, or when you start the test. All right, number 2B. Okay, it said use interval tests. Okay, so we have the absolute value of 2x plus 7 is less than 9. Well, the way we used interval tests was we ignored the less than greater than symbol and we just wrote it as an equal. And then we said, okay, well, how do I solve this problem? Now I did this in a couple of warm-ups, but it's also back in chapter 2. Okay, back in chapter 2, but I did this in class a couple times. Okay, this, remember, the absolute value inside could either be worth -9 or inside could be worth +9, because the absolute value of a negative or positive number is always a positive answer. So from that, we get 2x plus 7 equals 9, or 2x plus 7 equals -9. Okay, those are our two possibilities. So then we take away 7, so 2x equals 2 on this one, divide, x equals 1, or we get 2x equals -16, because take away 7, x is -8. Now the key here is these are not solutions, these are critical values. Something special happens at those. And so to figure out what that specialness is, we go back, okay, to our number line. This is where the interval test kicks in. We go back to the number line, we put -8 and 1 on a number line. We're going to put open circles there because our original problem was less than and not equal to. Okay, and then we're going to start picking numbers, random numbers in each interval. Okay, and maybe I should explain that. Make sure we get all talking the same language. So the interval from 1 to infinity, you pick any random number you want from 1 to infinity. But the key is you plug it into the original problem that we have so far ignored. So most of you would say, oh, I'm going to test 2. And you're going to plug it in the original problem. So you're going to have the absolute value of 2 times 2 plus 7 is less than 9. Okay, so you do your math, you get 4 plus 7 is the absolute value of 11 is less than 9, 11 is less than 9. Well, that's false. Okay, pick a number here and here, probably you'll test 0, because that's the easiest because we're lazy for any number between -8 and 1. Okay, testing 0, we're going to get a true. And back here, if you test -9 and do your arithmetic correctly, you get a false. Now, if you need me to show the work and all that kind of stuff, I'll be happy to do that, but I'm pretty sure those are correct, true, false, true. Okay. So then our answer is whatever is true. So our solution to this problem is parentheses -8, comma 1, close parenthesis. That means any number, any x value between -8 and 1 will make this problem true. And that's it. That's how you do it. So you pretend it's an equal, you solve the equal one, you test the equal critical values, and then you pick out whatever is true. And that becomes your solution. Okay or not okay?
Okay.
Okay. Anyone else?
Can we do the bonus question number 4 on exam 4?
2, 3, 4. Solve the system?
Yeah.
Okay. Can I erase my interval thingy here? Okay, I don't hear anybody yelling at me. Good. Now, I'm going to do this one not wrong, but hard, the hard way that some of you guys chose. And then I'm going to stop in the middle and direct us another way. So this is exam number 4, bonus number 4. And we have this system, xy equals 8, and x minus 2y equals 6. Okay. Now, this is the one that you guys made. Yeah, okay. No, I'm just going to do this probably the easy way. Look, if we could get x alone here. So for example, suppose we got x equals 2y plus 6. Taking the second equation, get x alone, we can plug it here in place of x. Remember, this is saying x and 2y plus 6 are the same. So we can put them together, and in place of x, we can have 2y plus 6, that x, times another y equals 8. This, I think, is the easiest way to do this problem. So the first question I would have to anybody is, do you guys understand my substitution? I took the second equation, did a little bit of algebra to get x alone. Okay, and then once x is alone, I plugged that knowledge into the first equation in place of x. So this is x, this is x, and this is x. That gives me 2y squared plus 6y equals 8, or 2y squared plus 6y minus 8 equals 0. Okay, you could divide out of 2, factor out of 2, have y squared plus, actually, most of you really took advantage of the polysolve. Okay. 3 and -1, I don't have it. Oh, -4 and 1. Yeah, so I get y is -4 or y is 1. I showed my steps on the online. Okay. So we get these y values. Then you come back up here and you say, if y is -4. So you have two values for y. Y is -4 or y is 1 if you use the polysolve feature. Okay. So then we have to decide, okay, what do I do with it? Where do I plug -4 in? It doesn't matter. Whichever one of these equations seems easiest. If you're going to get the same answer, you've got to. If you don't, there's an error. But let's say we plugged it here. If y is -4, then x is 2 times -4 plus 6, that's -8 plus 6, that's -2. So if y is -4, we had -2, -4 as one of our solutions. As one of the solutions. But wait a minute, what if y was 1? Okay, we plug it in again. X equals 2 times 1 plus 6. X was 8, so we have 8 and 1. So these are the two solutions to this problem. Okay, and that's, I think that's the easiest way to do this problem. There's another way which is significantly more complicated. Okay, anybody else? Other questions you want me to work out or do or show?
Will you be doing a review tomorrow night?
Online, no. On Tuesday night, yes.
Okay.
In class, yeah. Yeah. But I'm
No
hoping that-
flashcards?
Huh?
No flashcards for the
Nope.
final?
No.
Okay.
But you can do a brain dump onto a blank sheet of paper when you start the test.
You know, actually, so there was a problem regarding find the what was it? Actually, let me see. It was
On the exam
find the
number 4.
equation. Yeah, number 4. Find the equation of the line that passes through the points of number 1. And we've gone over this plenty of times, and I knew it. And I just drew such a effing blank, man.
Okay. No problem. Okay, so we had the 2 points. This is exam number 4. Problem number 1, actually C. But we have the point A, which is -2, 3. And we have the point B, which is 7, -9. Okay, so it wants the equation of line through these points. Okay, so, okay, what's the first thing I need? If it wants the equation of the line through those points, what do you need?
Midpoint.
No, you don't actually need the midpoint. You could use the midpoint, but you don't need the midpoint.
Instance,
Nope. To find the equation of a line, you need a point, you need a slope, and you need this formula. To find the
Okay.
equation of a line, you need a point, a slope, and that formula. So we have points up the yin yang. That's why somebody said, could you use the midpoint? Yeah, but you don't need to because you already have these. Okay. Okay. What we're missing is the slope. And by the way, we did, oh, this is number 2. I'm sorry. I beg your pardon. Wrong check. This is number 2. We found the slope in number 1, but let's redo it again. So the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which is -9. That's y sub 2 minus 3. Y sub 2 minus y sub 1 over x sub 2, 7 minus -2. Okay, notice the formula has a minus sign built into it. The fact that you get a minus minus, you have to be able to do the arithmetic to turn that into a plus. But we get -12 over 9. 7 plus 2 is 9. 9 take -9 minus 3 is -12. That reduces to -4 over 3. So our slope should have been -4 over 3. Well, what do we do now? Now I have a slope. So you pick a point. It doesn't matter which one. Eeny, meeny, miny, moe, this point's gonna go. Okay, I like that one. So we plug in everybody. We say, we use the formula y equals mx plus b. When y is 3, the slope is -4/3. X is -2 plus b. So this is 3 equals 8 over 3 plus b. Okay, take away 8/3 from both sides, and you guys, your calculator will do that. You get 1/3 equal b. Okay, I need you guys to listen up, because for some of you, I give you your test back on Tuesday night right away, your exam number 4. But from some of you, I wrote repeatedly, answer the question. Okay, answer the question. Several of you gave me all of this information, but you never gave me the equation of the line. You gave me the slope, you gave me the y-intercept, but you never actually told me how this works. The answer is y equals -4/3 x plus 1/3. That was the equation of the line. There's another problem that says, what was it? It said find the radius in this, or the center of the radius of a circle. Well, you did all of the math perfectly, but you never answered the question. You didn't tell me what was the center. You didn't tell me what was the radius. So again, those are dumb points. You didn't answer the question, so I have to take a point away. Okay. So a lot of you, I wrote, answer the question, read the directions, answer what the directions ask you to do. And anyways, that's the answer. So Chris, I think, does that answer your question or not?
Yeah, I don't know. I just drew a serious blank on some of this stuff.
Okay. Yeah, I know. There's all. Whoop. I'm good. Haven't found one set of earbuds yet that will stay in my ears. Not one.
What kind are those?
Oh, hell. M&M,
Beats?
no, they're not Beats. MW, whatever, whoever the MW is. And I have another set. I bought Apple Pro. My wife got me these, and my wife got me another set, and none of them stay in my ear. So I'm going to go to Walmart and get the kind that go over your ear, like an athletic or a jogging one. And that way, if they fall out, at least they're going to stay on my ear.
Don't get J-Labs. I just got some of those and they suck.
Oh, really?
Yeah,
Suck.
don't get JLab ever. They're awful.
Ever?
Ever.
Really? Oh,
Yeah.
Ever. They're so irritating. You're trying to turn up the volume. It's a mess.
Yeah, and when it hooks
Okay.
behind your ear, it's just so uncomfortable and pushes in wrong. They're awful. They're not made well.
really? Okay. All right. Well, that's good. That's good news, because I'm going to put these for sale. Somebody wants them for $50 or something like that, or less. I don't know. I mean, they're all,
Actually,
yeah.
I got a pair at Ross. They're called Skull Candies, and those things have actually been the best pair. They stay in my head when I'm running. They're
Really?
loud. Yeah, and they cost like $24.
Where'd you get them?
Ross.
Oh, at
You can
Ross.
you can you can stud yeah no you can stumble
Okay.
across like little deals, but the
Like,
brand's called Skull
okay.
Candy, and surprisingly enough, they're pretty good.
Really? And for
Mhm.
$24, I can afford to throw them away.
Yeah, exactly.
Yeah. All right. I Ross clothing for less. Well, not Skull Candy, but okay, whatever. Okay, I will look there then tomorrow. Thank you. Okay, usually my favorite shopping place is Big Lots, but that's showing you how cheap I am. All right, got time for one or two more questions, guys, and then I'm done for the night. One or two more.
Can we do number 2? Exam 3, number 2 on the back. Under the bonus questions.
Such a neat graph of that thing.
Yeah.
Okay. Or the take home part number 2. Yeah. Okay.
Yeah, I got it messed up on the inverses when I remember that.
Oh, okay. What did I do with my note? My notes? Okay, here they are. I'm getting dizzy. Okay. So this is exam number 3. Number 2 from the take-home part, which was graph f of x equals 3 to the x minus 2. All right, so here we go. We're going to start with the table of values. If x is 0, then this is 1 take away 2, negative 1. If x is 0, 3 to the 0 is 1. 1 take away 2 is negative 1. If x is 1, okay, 3 to the 1 is 3, take away 2 is 1. If x is 2, 9 take away 2 is 7. Okay, now let's go for the negatives. If x is negative 1, that becomes 1/3. 1/3 take away 2 is negative 1 2/3. Okay, or whatever your decimal was, negative 1.666, whatever you did. If x is negative 2, this is 1/9. 1/9 take away 2 is negative 1 what is that, 8/9, whatever that is, something like that. I don't know what the decimal is. Okay, and so on. That's good enough for us. So if we graph this, we have 0, negative 1, which is right there. And that, by the way, is the y-intercept. You just got it from your table. We have 1, 1. We have 2, 7. Somewhere up here. Okay. Then we have negative 1, and so negative 1, negative 1.666 is right about there. Not quite negative 2. Then we go to negative 2. Negative 2 is even closer to here. When x is negative 2. So if I'm not making sense, yell at me and tell me to show my work or explain more. But basically, if I plot these points, I get this shape. Okay. Notice the asymptote, no matter how small x gets, if x is negative 3, negative 4, negative 5, it will never equal negative 2. It will keep getting closer and closer to negative 2, but never equal it. So this asymptote of y equals negative 2, okay, is our asymptote for this problem. And that's the basic graph for this shape. Now, I know you asked another question on that, but I'll get to that in a second. But so there's the asymptote, there's the y-intercept, we got all that. So that's the basic exponential function. And that's its graph. That's what it looks like. Okay, remember how we talked about how a -2 or a +2 moves the graph up and down? Okay, well, that's what we have. So any questions about how my work got this graph?
So it's y equals -2, not y
Yeah, if,
-2.
well, I'm sorry, say again?
Like it's y equals -2, not y doesn't equal -2.
Look, the asymptote is the line. Okay, you've asked a really good question. The graph will never equal that line, but the line is y equals -2. It's called the asymptote. The graph will never equal that.
Okay.
The asymptote, that's the fancy word for the invisible line that my graph will never touch. That's what it means. Okay, asymptote. An invisible line that my graph will never touch. That invisible line is y equals -2. Okay? Now, how do I find the inverse? Notice I didn't ask you to calculate it. I just said sketch the inverse. Well, how do you do that? You reverse the ordered pairs. Remember, on all inverse functions, x's and y's got switched. So instead of 0, -1, you're going to have -1, 0. Then you're going to also have 1, 1, okay, because that switched. And here you're going to have 7, 2. Something like that. So if you connect those, well, okay, let's go some more. Now, here you're going to have -1.6666, -1. -1.666, -1. negative 1 point, blah, 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 negative 2. Okay, this graph is going to look like this. And how did I get that? All I did was flip flop my ordered pairs. Now, one last thing. If you swap X's and Y's, what will the asymptote? The original asymptote was Y equals negative 2. What's its inverse asymptote? It will be X equals negative 2, because you flip-flopped all of the ordered pairs, all of the X's with Y's. Everything that used to be a Y is an X. Everything that used to be an X is a Y. Is that okay? So I really didn't have to do any math at all. I had to think, but I didn't have to do any calculations because they were already right here. Okay, guys, that's it for the night. This should whet your appetite, study a little bit more tomorrow, and come with a whole bunch more questions. I hope I handed this out. I know you can't read it, but I handed it to everybody as they left. This is a breakdown of exactly what's going to be on your final exam. Okay, exactly. I handed this to you when you left class the other night. Okay, so kind of make sure you read it, bring it to class, and have me explain things. If you don't understand them, explain things, because that will help you focus on what's on Wednesday night, what's on Thursday night. So you don't have to study for everything all at once. Okay.
So
Yeah.
when Tuesday will be purely review, correct?
Yeah, and by the way, I should point out, you do not need to, just like this, tonight was optional, Tuesday's optional. Okay, but I think most of you need it, but, or would appreciate it at least. But, yeah, Tuesday is just a review, just like tonight. Okay,
Okay, cool. Thank you. And that'll be the last review we have, correct?
yep, that's it. And then Wednesday we take part 1, Thursday we take part 2. Okay, and Friday we all go cry on our beers.
Okay, sounds good. Thank you. Have a good night.
Okay, bye bye. Anybody, any other questions? I'm going to stop the recording.
No, thank you. Have a good night.
Okay, you